testing hypotheses about variance. If you're interested in hypotheses about variance or differences between two variances, you can use an F statistic named for Sir Ronald A. Fisher. You construct a ratio of two variances, and it turns out they're distributed in a very characteristic pattern. We use an F sampling distribution, for that's what Fisher discovered, was that ratios of variances, one variance divided by another variance, or one variance over another variance, is a very characteristic distribution that has been named the F distribution, or the F sampling distribution. Now, it's not a single distribution. It's positively skewed. It varies with degrees of freedom in the numerator and degrees of freedom in the denominator. There are different curves for each degree of freedom, and its range F is always greater than or equal to 0. So here's an F distribution with 4 and 20 degrees of freedom. Its values go from 0 to positive infinity, and you can see that if you were doing a hypothesis test in which you set your alpha to 0.05, you'd be interested in an area under the curve of 5% or 0.05 down over here. So if your ratio was variances in here, you would reject the null hypothesis. If it was in here, you would fail to reject the null hypothesis. F distribution has 2 degrees of freedom in the numerator, degrees of freedom in the denominator. Now, if you change that, you'll see that you get a slightly different curve. In this case, an F distribution with 4 and 20 is in blue, and an F distribution with 20 and 4 is in pink. And you can see that they are different distributions, and that will change the area. That will change the value in which you would reject the null and values in which you would not. So there's different decision-making criteria based on where your degrees of freedom are. It's pretty easy to do. You just compute the ratio of the variance, you make sure the degrees of freedom are correct, and then in Excel you can use fdis.rt to find a p-value. I know this seems really simple and really straightforward, and it is, but that's how you test hypotheses about variances.